Felguera IHI, a subsidiary of the Duro Felguera Group specialized in hydrocarbon storage, is building two of the largest liquefied natural gas tanks that currently exist on the market at the port of El Musel in Gijón. These enormous tanks will store the gas arriving by ship to the regasification plant that Enagás is constructing on the grounds belonging to the extension of the port El Musel, occupying around 18 hectares. Regasification plants receive natural gas in a liquid state by sea, store it and turn it into gas before sending it to the grid to be used by consumers. The regasification plant at El Musel is a maximum safety and security installation, as its design, construction and operation are subject to the most demanding European and international standards. Both the gas-carrying vessels that transport the gas and the storage tanks comply with the strictest safety regulations. From an environmental protection viewpoint, the regasification plant will not emit solid waste, fumes, liquids or polluting gases. Besides, natural gas is the most environmentally friendly fossil fuel. Moreover, the seawater used in the vaporization process of turning the liquid into gas is returned to the sea with just a slight decrease in temperature. The storage tanks are the heart of the regasification plant. They store the liquid gas so that it can later be turned into gas and pumped into the general grid. The tanks built by Felguera IHI at the regasification plant in El Musel are full containment tanks, protected and isolated from the outside, and of the cryogenic type, as they store the gas at a temperature of 173 degrees below zero and at slightly higher pressure than ambient atmospheric. With a diameter of 78 meters, these tanks are larger than a bull ring. Their 50-meter height is comparable to a 15-story building. Inside, they can store 150,000 cubic meters of liquefied natural gas, the equivalent of 60 Olympic swimming pools. The weight of the dome is 600 tons, equivalent to 600 cars. The tanks consist of an internal 9% nickel-steel alloy container to store the product at cryogenic temperatures, a secondary tank of the same material to contain the gas in case of a leak, and an external cryogenic concrete tank lined with carbon steel that guarantees that the tank is gas-tight. The thickness of the outside wall is 800 mm and is designed to support earthquakes or possible gas leaks. The roof dome of each tank is made of 27 steel sections that have been manufactured by Técnicas de Intibación, TEDESA, another Duro Felguera subsidiary. Hanging over the internal tank from the dome by means of a series of rods is an aluminium membrane covered by glass fiber blankets that insulate the tank. There is a platform on the outside of the dome to support the various gas intake and outlet pipelines that go down the external wall to the pump area from where the gas is sent to the plant's vaporization system. Other measuring and control systems are also installed on the outside of the tank, as well as two sets of stairs and an elevator. The construction of the tanks lasts 36 months and starts by compacting a 16-meter-high embankment, where a foundation slab is laid to guarantee that the ground remains stable. At the same time, an 800mm thick and 41-meter high concrete wall is built, to which a 600-ton steel dome is welded. Once the modules making up the dome are assembled and placed inside the tank, an aluminium roof is hung from it and the whole structure is lifted onto the top border of the concrete wall. This operation, lasting about 4 hours, is carried out using air generated by huge fans at a pressure that is higher than the total weight of the roof, 700 tons. The internal wall of the outside tank is lined with carbon steel, and the secondary tank is assembled with 9% nickel alloy steel sheets. Then a reinforced concrete ring is built on the ground onto which the main tank is constructed, and which is also made of alloy steel. Various layers of leveling concrete are placed at the bottom of the tank, along with foam glass blocks and sand. Once the inside piping systems of the tank are in place, a hydrostatic test is carried out and insulation is finalized using expanded perlite between walls and fiberglass on the suspended roof to cushion any possible distortions due to temperature changes. On the outside of the dome, which has previously been concreted over, the gas intake and outlet piping systems are installed, which go down the outside wall to the valve platform. Safety, instrumentation and other equipment are also installed along with 2 sets of stairs and an elevator. The final process consists of drying and purging the tank and pipes by injecting nitrogen at ambient temperature, which eliminates any humidity and oxygen so that the tank may be cooled down and start up. The tank receives gas pumped from the gas carrier through pipes. The gas is then sent by primary pumps under the tank itself to the secondary pumps, located in the processing area. It is these pumps that give the gas sufficient pressure for it to be sent to the general grid once it is vaporized. The tank can be filled in 2 ways. From the top, if the gas from the gas carrier is colder than the tank, or from the bottom, if the temperature is higher in the gas carrier than in the storage tank.